Hello everyone, this is Badrinath Malkapuram, 18BEC0394 of C1 slot, and my serial number is 31. So, coming to the digital assignment 2, our first question is explain how the selected paper related to CO syllabus. Module 1, topic related to research paper. The ALU discussed in floating point addition is of non-Newman architecture, and the module 2 is related in a way such floating point arithmetic is used for the binary operations. Module 3, improvement of spatial reuse throughput using ASK or CSMA protocol in wireless ad hoc networks. And topic 4 is like related in a way such all the essential addressing modes can be used here for all binary operations to increase the clock speed. This means that according to Moore's law, feature size scaling in increasing exponentially in transistor per integrated chip. Therefore, more memory is used in the less space. This is how module 4 is related. And coming to module 5, input outputs are parallel ports and multiplexer is used to select one. And coming to module 6, it is related to in such a way that 7-stage pipelining is used in the proposed floating point adder, and module 7 in such a way processor level parallelism is followed. Wireless networks present several challenging issues for the network designer that are quite different from their wired counterparts. An impairment that is due to broadcast nature of the wireless network is interference, since all the nodes share the same physical medium. Simultaneously, transmission may result in the interface at the received nodes in networks that to do employ code division, multiple access, medium access control protocols such as IEEE. This is how all the 7 modules are related to my paper. And coming to the second questions are asked about the existing architecture discussed in the paper using appropriate raster graphics editor software in the encapsulated post. So in the EBS format, Sarah has it. And again the same software that is used in the DA1, I have used it and drawn it and uploaded in the top. And for the third questions are asked about the graphs and tabulated results and graphs using Office Suite in encapsulated PostScript file format, that is EBS format. So data rate is 1 megabyte per second. Simulation duration 4000 seconds. Warm up time 400 seconds. Routing protocol AODV. Channel model is two-way propagation. RTS threshold is 150 bytes and transmission radius 250 meters. We discussed various design issues concerning the OCSMA protocol. In particular, we compared and contrasted the OCSMA protocol with the IEEE 802.11 MAC protocol on which it is based. And in the fourth one, Saraj proposed architecture discussed in the paper using diagramming and vector graphic application for the software. So again, this is also drawn in a separate software and given it to the sir. Transistor level internal diagrams using electronic schematic capture. So this is how it looks. And in the sixth question, Saraj compare the proposed architecture with existing architecture in your reference books. As per in we have to compare the architecture that is used in reference books and our existing architecture. A timer at the primary transistor is set to expire upon completion of the secondary handshaking. Note this is that it's a TAV timer will not be set during the transmission of the secondary handshaking. We note that this differs from the typical NAV implementation of IEEE 802.11 protocol. When the timer expires, it transitions data frame to primary receiver. The secondary transmitter starts in an overlap transmission after the commencement of the primary transmission. This overlap delay 0 is designed to allow the secondary receiver to acquire the timing and phase of the primary transmission, which greatly simplifies the IC mechanism at the PHY. It does not ensure perfect symbol or phase and synchronization of the primary and secondary transmission of the secondary receiver. The format of the overlapped data frame is the same as the data frame. The secondary receiver cancels the interference and recovers the overlapped data. This improvement of special reuse throughout using OCSMA SMA protocol is wireless ad hoc networks. Phase is illustrated in figure 8, which is deposits node be receiving an O data frame while cancelling out the interference caused by cease transmission. Note that the secondary transmission is allowed to terminate 1 second after the end of the primary transmission. Advantage of the proposed design over the existing design. Since the secondary receiver has non-causal knowledge of primary transmission, it can mitigate the interference due to primary transmitter and recover the intended message. However, the secondary transmission causes interference possibly to several primary transmissions. We evaluate the amount of interference that a secondary transmission may cause at the primary receiver and suggest how this interference can be controlled by adapting the power level of the secondary transmission to meet the specified signal to interference ratio called as SR, and the outage requirements are by careful selection of the secondary transmitter. And the merits and demerits of the proposed and existing techniques. Merits of existing technique. The power efficiency calculated for the single axis solar tracker is said to be 25% more than the that of the fixed amount. Demerits of the proposed technique. The power output for the dual axis and the fixed mount panel are tabulated for a single day. The average power values prove the dual axis panel produces more power than one of the fixed amounts and the single axis tracking technique. Application of proposed design. This paper developed overlap transmission schemes to enhance the spatial reuse the and throughout of wireless centers by taking advantage of priori knowledge of the interfacing packet. The receiver can employ a simplified IC schemes to receive a packet in the presence of interference. It is analyzed some of the factors that limit the use of overlap transmission in and flowchart of algorithm or transistor level circuit proposed in the design and we have to do it in the APS format. The long latency of division and square root operations is mainly due to algorithms used for these operations. First order international algorithms and binomial expansions. Algorithms are commonly used for division and square root implementations in high performance systems. These algorithms exhibit better performance than subtractive algorithms, and an existing floating point multiplier can be shared among iterative multiply operations in the algorithms to reduce area. Even so, it still results in a long latency to compute one operation, and the subsequent operation cannot be started until the previous operation finishes, since the multiplier used in the algorithms is occupied by the several multiply operations of the algorithms. Liddycott and Flynn proposed a multiplicative division algorithm based on Taylor series expansion. This algorithm measures fast computing by using parallel powering units such as squaring and cubing units, which compute the high order terms significantly faster than traditional multipliers with a relatively small hardware overhead. So this is a flow chart I asked for. Thank you everyone. This is about my assignment. Assignments 1 and 2.